Okay, here's a good question trying to understand um, the concept of dissociation and how many moles of ions you have. All right, so they say in solution A, I've got a volume of 3 liters and I have a concentration of 3.39 moles per liter. And then in solution B, I've got a volume of 2 liters and a concentration of 2 moles per liter. Okay, so this is in a beaker. Oh, and this first one is sodium chloride. So I could write a dissociation equation. It looks like it's a 1-to-1-to-1 relationship. And this next one is silver nitrate. So if you dissolve that in water, you get silver ions and nitrate ions. And again, it's all 1-to-1-to-1. So then they say to put them together. So we put them together in one big beaker we call C, and in there I've got, so I'm going to have this and this and this and this. Those are all the ions that'll be floating around in that beaker. Silver and nitrate ions. Okay. All right. I think we're okay. My one issue here is that I wonder if there'll be a chemical reaction that'll happen that'll take some of those ions out of solution. But that's a question for a stoichiometry kind of question, not for dissociation. So let's just play the game, assuming that all of those stay as ions. Okay, so first off, let's figure out how many moles of chloride ions I'd have, because the question says calculate the concentration of chloride ions in this final solution. So let's find out how many moles of those we have. So concentration is moles over volume. I'm using that formula because I know those two numbers. So moles is equal to C times V. Concentration is 3.39 moles per liter times the volume is 3 liters. Okay, so when I multiply that together, that comes out to 27 to 110. 10.17 moles. Okay, and that is moles of chloride ions. I guess this was concentration sodium chloride, but since it's a 1-to-1 relationship, the moles of sodium chloride that I have, which is 10.17, is going to be the same as the moles of the chloride ions of these guys. So this concentration will also be 10.17. Now, the other solution doesn't have any chloride ions in it. And so if it doesn't, I don't have to worry about figuring out moles on that side. But I do have to worry about that volume. So now, if they want to know the concentration of chloride ions in that solution, so how much of this do we have? The formula is moles over volume. And so the moles I have are 10.17 moles divided by, now here the volume would be the total volume of stuff that's inside there. So I've got 3 plus 2, so that's 5.00 liters. Okay, if I divide that, I'm going to get 2.03, just a second, 4 moles per liter. Now if I round that to 3 sig figs, 3 sig figs, it'll be 2.03 moles per liter. Now notice I didn't have to do anything with moles on this side. If the question though would have said, let's do a different question. So if the question would have said, calculate the concentration of, say, nitrate ions in the solution. So if they want to know the nitrate ions, then I'd have to know how many moles of nitrate I have. So then I would go and use that other formula. So C equals N over V, and that'll change to N equals C times V. Concentration 2, volume is 2, cancel the liters. So that would be 4.00 moles of silver nitrate. Since it's 1-to-1, that would also be the number of moles of nitrate ions in that, I guess, in this first solution. So when I dump it in all together, so I have 4 moles still, because there's no moles from anybody, there's no moles of nitrate over here. So I still have 4 moles of nitrate when I dump it into the second beaker, or the beaker C, but my volume is up. So my concentration for nitrate ions would be moles over volume. Moles are 4, and the volume again would be the total volume. So 3 plus 2 would be 5 liters. So 4 divided 5, I think, is 0.8. With 3 sig figs, it'd be 0.800 moles per liter. So that would be equal to the concentration of nitrate ions in that solution. All right, hopefully that helps you. Sort of a tricky question, because you first have to figure out moles of whichever species they want you to. And once you have moles of that, then you can take that moles and divide it by the total volume, because they're dumping both those beakers into one. Now, like I said in the middle there, this question isn't the best question, because if you look, silver and chlorine, if you look at those on the solubility table, those will react and form a solid. And so if they were asking for chloride ions, it would be less, this concentration would be less, because those would have formed a precipitate. And so the chloride ions would have come out of the solution and formed a solid. So there wouldn't be as much of a concentration. But I don't think that's what they're going for this question. All right, hopefully that helps you out.